There are four macromolecules that we're going to be talking about as we go through this unit. They are carbohydrates, proteins, lipids, and nucleic acids. What we're going to focus on today are carbohydrates. So when we look at these large macromolecules, they're basically built from smaller molecules joined together. So simple sugars make up polysaccharides or carbohydrates, which we're going to talk about today. Nucleotides are smaller molecules that build together to produce nucleic acids. Amino acids are small molecules that build together to produce proteins. And lipids are a little bit different, but they are a combination of fatty acids and glycerol. So if we look at carbohydrates, carbohydrates are sources of energy for our bodies. And in terms of their chemical composition, they're made up of three elements: carbon, hydrogen, and oxygen. So if we look at those, carbon has the element or the symbol C, hydrogen has the element H, and oxygen has the element O. Now, hydrogen and oxygen are at a ratio of 2:1, which means there are twice as many hydrogen as there are oxygen. So if we look at glucose, that's a very simple sugar made up of a ring of basically carbon. So even though they don't show them in here, there are actually carbon atoms at each of these junctions. So this is basically what the element looks like. If we write down the chemical formula for glucose, it is C6, meaning there are 6 carbon, H12, so there are 12 hydrogen, O6, meaning that there are 6 oxygen. So you'll see in terms of oxygen and hydrogen ratio that it's a 2:1 relationship. There are twice as many hydrogen as there are oxygen. Fructose is another simple sugar, which is the one on the right-hand side. If we look at sucrose, this is actually called a disaccharide, meaning that there are 2 sugars joined together. So sucrose, if we look at its chemical formula, would be C12, H22, O11. So there are 12 carbon, 22 hydrogen, 11 oxygen. So you could actually add those all up if you wanted to actually pause at this point. But again, all of these, this is basically a ring of carbon. So for where every angle is, this has actually got a carbon, even though it's not showing in this particular diagram. So again, if we look at the relationship here, there are 22 hydrogens, 11 oxygens for sucrose. And again, it's at a 2:1 ratio. So carbohydrates, these are small sugar molecules that you have in soft drinks, but they can also be very large molecules like starch that you would have in pasta and potatoes. So in terms of what their function is, it does provide us with an energy source, but also a way to store energy. So we can use the energy at a later date if we have too much at a certain point. So for animals, we actually store these complex carbohydrates in muscle tissue and in liver, and it is called glycogen. So these are some different types of carbohydrates. Polysaccharides are the very large macromolecules, but we can have monosaccharides, meaning there is one sugar molecule. So things like glucose we looked at already. Fructose was also on that slide. Galactose is another simple sugar. Then we can have disaccharides, the di meaning 2. So there are 2 simple sugars, things like sucrose, lactose, which would be in milk, maltose, and then polysaccharides, which would have lots of these monosaccharides joined together, so many sugar molecules. So things like starch, glucagon, and cellulose, which is basically a type of fiber. So when we actually join these molecules together, when we have a monosaccharide and we have to join them together to form a disaccharide, what we have is something called a dehydration reaction, and that's what joins the 2 monosaccharides together. So if we look at two glucose molecules, here and here, basically what happens is we take and remove oxygen and hydrogen from here, hydrogen from this molecule, and what do we get? We get H2O, right? Two hydrogens, one oxygen. So we're removing water, which is why it's called a dehydration reaction. And then what's left behind is an oxygen. So this oxygen now joins those two molecules together. And that's what creates disaccharides. If we take a molecule of glucose and a molecule of fructose, and we do the same thing where we dehydrate it, taking out oxygen and hydrogen from glucose and taking out hydrogen from fructose. So what are we removing? We're removing water. So we're basically a dehydration type of reaction. What's left behind is oxygen. And so we now have another linkage that's joined these two monosaccharides together, and we now have sucrose. So polysaccharides basically are ways that we can take lots of monosaccharides and we can join them together. If you take an example of starch, which is a type of polysaccharide, what we do is we link together glucose monomers. And there's a slight difference between these. This is called alpha glucose and this one's called beta glucose. If you looked at their formulas would actually be the same. They would have C6H12O6. However, the way that the atoms are joined together is a little bit different. So if you look at this particular glucose, we have these two, which are oxygen and hydrogen, fairly close together. If you look at the beta glucose, these are actually called hydroxides, by the way. These are in a slightly different location. And when we put them actually in a different location, we change the structure of the molecule, and that actually changes the way the molecule reacts, kind of some of its features. So if we have alpha glucose and we put four of them together, we can create starch. If we take beta glucose, put four of them together, we can get cellulose. So again, we can have a dehydration reaction, which we've already looked at, where we're taking monomers or monosaccharides and linking them together. Each time we do, if we have a short polymer that has three monomers or three monosaccharides together, we can have a dehydration reaction to link it up with another monomer that's not linked up. And we can create a longer polymer by doing so. Now, not only do we need to be able to have these large molecules and be able to build them, but organisms need to be able to break these macromolecules down. So once we put them into our body, we have to have a way to be able to basically use them for digestion and energy for ourselves. So to do that, we have to take these large molecules and break them down. Now, this process is called hydrolysis. So basically what we do is we take a large polymer and we start to cut it apart. So anytime we want to break a bond in a polymer, like this 4-carbon polymer, then what I need to do is add water. When I add water, I give the polymer the hydrogen, the monomer the hydroxide or hydrogen and oxygen, and now I have broken it apart, and now I have a smaller polymer and a monomer created. I can keep doing that process, that hydrolysis process, to continue to break this molecule down. And that's basically what our bodies are doing when we ingest large polymers or carbohydrates. So that's where we're going to finish for today. We'll look at proteins, lipids, and nucleic acids further along.